This is Rob, Mr. Rob Jerdonek, is that correct? Okay, great. You're from the Bay Area, and you've had several years of experience in software development of tools in security for companies. All right, so with that, please give Rob a warm welcome, and here we go.
Thank you. Yeah, I'm Rob Jerdonek. I work at the Trust Engineering team at Roku. At Roku, we call the security team the Trust team. It's pretty much the same thing, but I kind of like that we call it the Trust team because it keeps in mind what our end objective is, and is that achieving customer trust. And obviously, security is essential to achieving customer trust. And today I'm going to talk about our approach to vulnerability management. I'd also like to acknowledge Lily Chau, who helped prepare these presentation slides. Here we have the CEO of Roku, Anthony Wood, and he was asked a question of what he thought about highly interactive television. And he responded in the media that many companies just don't really understand the attitude people have when watching TV. They really just want to sit there, drink their beer, and watch TV. And for beer, you could substitute anything else you might enjoy, like popcorn or herbal tea or whatever you enjoy. But our question was, is the same true for developers and vulnerability management? But being at the lobby yesterday, I think there are quite a few developers here who really enjoy their beer. Yeah. So I think we're onto something. Our vision is that receiving this vulnerability data should be as simple as streaming the latest episode of your favorite TV series. We set out to build a platform to make this vision possible at Roku. And this presentation focuses on our static code scanning, but these same principles can also be used for dynamic security testing. As we sat down to think about this platform and create our requirements, we decided we wanted to have a pluggable framework. We have different scanning modules, technologies. For a Python application, we need a special component to scan Python apps. Likewise for Java apps, Terraform files, etc. We want to be able to plug in different technologies as they become available. Our system also needs to be very scalable. We need to be able to continuously scan hundreds of applications or even thousands. Next, we need a very flexible integration. We have a variety of, Roku has grown by acquisition, like many companies. We have a variety of systems for CI/CD integrations, GitLab, GitHub, a variety of systems that developers use, and there'll probably be many more in the future. And underpinning all of this is developer happiness. We aim to delight our customers, and our customers in this case are the developers using the system. About the design of our platform, the heart of the platform is a Jenkins cluster that we run in Kubernetes. And this gives us the ability to auto-scale up and down. And this way, this cluster can perform automated scanning of hundreds of apps. And it could go up and down as demand rises and falls. And then from there, we have our scanning bots. These are a scanning bot to us is a scanning tool that we containerize according to a specific format, standard format. And each scanning tool is containerized as a bot, and Jenkins has the ability to run these bots in a certain order as needed to scan different artifacts and applications. Next, we needed a database and dashboards to store the vulnerabilities, and we decided to use Elk, Elasticsearch, Logstash, and Kibana. And that enables us to store our vulnerability data, search the data, analyze it, create dashboards, and so forth. Next, we have an integration layer where we we actually integrate with the CI/CD pipelines. And there, a main goal is to detect vulnerabilities in merge requests, pull requests, and notify developers before the code gets merged into the main branch, and definitely before the release. We also have integrations with Slack, because most of our developers use Slack, and this is a way they can receive these alerts as well. So we want to meet the developers where they are and give them timely and actionable vulnerability information. We also developed our own viewer tools, web-based user interfaces for users to view this data in great detail. Here's a diagram of our platform. Again, at the heart of this is our Jenkins cluster, and we have different scanner bots for different technologies like Go language code, Python code. We have a scanner for Java, JavaScript, a secret scanner, and we interface with the CI/CD pipelines, which could be GitLab, GitHub. And we also interface, we use JFrog Artifactory for our container images, so we pull from there to scan any images that are created by developers, and we have a scanner bot for scanning containers. These scanner bots write their output to S3 storage, and that's really just short-term storage. And then periodically, we have our Elk stack will import this S3 data using Logstash, import it into an Elasticsearch database. And that's where we can query the data, we can create dashboards, and have long-term storage of the vulnerability information. There we can also, automate the process of creating JIRAs to the click of a button, and we do require someone in the trust team to approve the JIRA before it's created when that's necessary. So these are some of the different scanning bots we have created. Each one is a containerized tool. We have a semgrep, containerized semgrep, which runs static analysis for Java, Python, JavaScript, Go, and Ruby, and other languages. For Java composition analysis, we have both OSS index and dependency check tools. OSS index also supports Go and Python. We have containerized NPM audit, so we can do composition analysis on Node.js apps. We have Bandit for Python code. We have TFSec for scanning Terraform files. Trivy for container scanning, and GitLeaks for secret scanning. We also use Retire.js, which mainly for client-side JavaScript, because we found it works well with that. All of these are open source tools that anyone could use. We just found it convenient to package them in containers, but we could also support commercial tools. If there's a commercial tool we want to use, we can just package that in a container as well and run it as part of our overall framework. Here's a screenshot of a Jenkins pipeline. If any of you have used Jenkins, each software repository, a pipeline will automatically be created to scan that software repository. And there's a sequence of steps called stages. And we start with a discovery stage where we have a container that we created, which its job is to scan the code and look for what kind of files are in the project. So if it has Python code, we'll trigger our Python scanner. If it has Java code, we'll trigger our Java scanner, and so forth. So that process is automated. And a nice thing about using Jenkins is it has the ability to parallelize the stages, so we can run all of these different scanners at the same time, and that really improves performance, because if you're giving real-time information to developers, you want to have really quick response time. Here's an example of some of the issues we can find with our framework. If there's a vulnerable third-party library in one of the applications, we have the OSS, like in this case at Java, we have OSS index dependency check. We could find if they're using, for example, an insecure version of log4j. We could recommend that they update to the latest version of log4j. For secret scanning, we run git leaks, and we could identify if a developer put a hard-coded key, a secret AWS key, for example, and we can detect that immediately and alert the developer, ask them to invalidate that key, create a new key, and store that key more securely. The next two examples are with semgrep, static code analysis. When we scan Python files, it turns out the default XML parser in Python is not very secure. If we see that, we recommend that the developers use diffused XML. It's a more secure Python parsing library. If we see any use of, for JavaScript, if we see like dangerously set inner HTML, that's an unsafe function, we'll flag that and recommend a secure alternative. Now I'll talk more about our CI/CD integration. So we have a variety of CI/CD systems at Roku. We're unfortunately not standardized, but you may have other big companies may also encounter this. But the GitLab is probably the most popular at Roku. And for this, we have a webhook integration. It's a pretty simple one-time setup. It can actually be done by the administrator, so the developer really doesn't have to do anything. So we set up this webhook for their repo, and this, anytime the developer creates a merge request, pull request, or updates that merge request, it will scan their code automatically. And they'll receive an alert, something like this. It will say, the Trusty security scans found some vulnerabilities in your code. Please click here for details. We don't bombard this view with lots of detailed information because the screen real estate for a developer is very small, and we just give alert basic information. And then we have a link where they can click to dive into all the details. And then from there, they can go ahead and fix the issues, and once they commit the code changes to fix those issues, the scan will just automatically run again because it'll be triggered by the commit, and hopefully the issues are fixed and they'll get another alert that just says security scans did not detect any vulnerabilities. As I said before, we created our own viewer application just for when the developers click on those links, we pull up a detailed view of the vulnerability. In this case, it was a purposely vulnerable application. It had a hard-coded RSA private key in the code, and we just point that out on line 15 of this file, and we have a link to that file in the GitLab or GitHub repository and instructions to fix that. So as I said before, we are using ELK for our database and dashboards. Just took some screen captures. We have dozens of different dashboards that we created with Kibana. It's a open source free tool. And one of them, we can capture all of our vulnerabilities by category across all of our repos that we've been scanning. And this helps the trust team see where any problem areas might be popping up, vulnerabilities that are frequent, and then we could focus on our remediation efforts on those highest occurrence vulnerabilities. Likewise, we have a number of line graphs to track remediation of vulnerabilities. This was from a CVE that over time we saw that the CVE had many occurrences, and as we remediated the issue, we saw the graphs going down, and we wanted to see all these lines sloping downward. And of course, if there's a new CVE that comes out, the graphs will go up, and we can monitor over time and see them going down. So picture is definitely worth 1,000 words. So we're not done yet. We're still enhancing our system, and next step is we're modifying our pipelines to generate a software bill of materials, SBOM. Currently, we only flag if a file exists in the artifact or repo if it has a known vulnerability. But while we're in there, we might as well create a full software bill of materials, and we could store that SBOM in Elasticsearch, and then we could have the ability to query that with our Kibana tools. And the big advantage of that will be if tomorrow there's a new vulnerability that comes out in a supply chain vulnerability. They always ask the security teams, do we have that? Are we using that component that's everyone's worried about? They want to know from the security team right away. And now, if we have this SBOM, we could quickly query all the SBOMs for all of our applications, and we will know if we're impacted by these supply chain issues, because there's been several in the past year, and I'm sure there'll be more in the future. And then, because the alternative would be to just wait until a CVE is created for that file, and wait until we run another scan of all of our repos, and that could take many days. But with the SBOM, we could quickly determine if we're affected by any kind of issues like that. Another area of future work is blocking merge requests when vulnerabilities are detected. Currently, we just simply notify developers if they have any potential vulnerabilities in their code, and it's their responsibility to fix them. But we are looking into the ability to block them, especially for any highly critical vulnerabilities. And yeah, we're looking at improving our coverage for different languages and technologies, because developers are always innovating and using more technologies, and we have to adapt our tool to keep up with that. And we want to definitely reduce false positives wherever possible. And we'd also like to publish our implementation details to the community, because as we've been talking about this with other colleagues at other companies, we see there is a big need for platforms like this in the open source world. And we'd like to consider open sourcing our framework code, especially if we find others who are interested in working with us. And Roku is hiring in our security team. There's a link to cybersecurity jobs if you're interested. In conclusion, all of us are using a wide variety of scanning tools, both open source and commercial. We're scanning our code constantly for vulnerabilities. And what's needed is a platform to bring this all together in a consistent way. And not only that, but a mindset of, quote, streaming this vulnerability data to the developers that's focused on really extreme simplicity and ease of use. Developers are super busy, and we need to really value their time and give them actionable, important information when they need it. And there are other platforms like this out there. There's commercial products that are trying to do something like this. I'm sure if you go out there in the vendor booth, one of those companies would be happy to sell you something that does all this. But we want you to know that you could build something like this with just open source components, like we have done. You could use Jenkins for automation of the scans, containerize the bots of open source scanning tools and run those. You could use Elk for your database and your dashboards, and you could build something like this purely from open source. And you may not exactly end up with exactly what we have, but hopefully you can use the same type of principles and think about bringing all your vulnerability data together into a consistent architecture. All right, thank you very much.
Excellent. I really loved that talk. I do. I mean, I look at source code all the time for customers. And what about SonarQube? Twistlock? Is Twistlock free? I think SonarQube has a community edition. But
Yeah, there's a lot of really good commercial tools out there as well. We just decided to do using open source technology just because we could really tailor fit it to what we needed. But the same principles could be applied to a number of commercial tools as well.
Well, y'all got it together, I'll tell you that much. All right, so folks out there, questions? Comments? Oh, there we go. Okay, let me talk to this person real quick. Who raised their hand over here? Okay.
Thanks. I'm wondering what's the latency introduced in build times due to all of these containerized bots and what developer feedback has been?
Sure. So what our approach is to run these scans during the merge requests or pull requests and automatically run when they create or update a merge request. And the scans, depending on the size of the repo, it could just take a minute or two, or it can take 5 or 10 minutes for the larger applications. But our decision is we won't block them from deploying their code. So even if they want to go forward with the merge request before the results are ready, they can still go ahead and do a build, especially if it's an urgent situation. But typically, merge requests do have a significant time because that's when developers do the code reviews, when they're reviewing the code before it's merged and released. So there usually is a period of hours or more where we have the opportunity to do this scanning. So we have not had any complaints about this taking too long, and we're not blocking them from proceeding with their build.
Fantastic. Okay, someone else, you had a question.
Yeah, so you mentioned you want to reduce false positives. I mean, the entire industry actually wants to do that. So what are you actively doing specifically to reduce false positives?
Right, yeah, so we have scanning rules. Since we're building our own tools, we're able to customize the scanning rules, and we're able to, if their issues are flagged in our viewer as false positives, we can review them, and if one app reviews it, we can consider if it applies to others. So it's a learning-based feedback system. So as we see false positives popping up, we can just adapt our rules to that for future. But yeah, it's an ongoing battle, but there's no way to avoid it, but it's something we are constantly improving and learning from.
Excellent. Other questions out there? Yeah, sure.
Sorry, make you come all the way up here. Yeah. Do you get any repeating offenders for developing teams that continuously release vulnerable code? How do you manage that?
Yeah, there are teams. Some teams are much better than others resolving issues, and we have these dashboards, so we can actually track across different teams. So we know from our dashboards which teams are better at responding to these vulnerability alerts than others, and then that requires a more personalized approach to work with those teams and understand if there's any underlying issues, why they're not fixing the issues promptly. And we have really precious few resources in our team, so we want to use our resources to meet with those teams that have these kinds of problems the most. And that's where the Kibana dashboards really help us really zero in on any product teams or application teams that need that extra support from the trust engineering team.
Oh, very good. Yeah, I often thought about in the future of using machine learning to pick out bad developers in code. Mm-hmm. Or, bad code always copied off of off the web, right? So any other questions before we wrap up here? All right, well, y'all have been a tremendous audience. Rob, you've been a fantastic speaker.
All right, thank you.
All right. Thank you very much, sir.